Good morning, students. Let us continue with Chapter 9 Force and Laws of Motion. In the third session today, we will discuss momentum, second law of motion, its derivation, and some related example problems. Before we study about the second law of motion, let us observe some facts and terms. First of all, take the example of a cricket ball and a tennis ball hitting you. Which of the two do you think can hurt you more? Obviously, the heavier cricket ball. This proves the first fact: force required to stop a moving object is directly proportional to its mass. Now, let us take two identical cricket balls of same masses, moving at different speeds. This time, which of the two do you think can hurt you more? Clearly, the cricket ball that moves at greater speed. This proves the second fact: force to be applied on a moving object is directly proportional to its velocity. Greater the velocity, greater is the force required. Now, combining both the facts, we come to the third fact that says force is directly proportional to the product of mass and velocity of an object. This product, mass and velocity, gives us a new term, momentum. The momentum P of an object is defined as the product of its mass m and velocity v. Momentum is denoted by small p equal to small v into small m. The momentum has both direction and magnitude. That is because velocity, being a vector quantity, has direction, and therefore the direction of momentum is same as that of velocity v. The unit of mass is kilogram and the unit of velocity is meter per second. Both the units combined together give us the SI unit of momentum, that is kilogram meter per second. So from these terms, we understand that the force applied is directly proportional to the momentum, or to the change in momentum, or to the rate of change in momentum. Here, rate means momentum changing within a time t seconds. And this is Newton's second law of motion, which states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Now, let us derive the second law of motion. Suppose an object of mass m is moving along a straight line with an initial velocity u. It is uniformly accelerated to velocity v in time t by the application of a constant force F throughout the time t. The initial momentum of the object will be P1 equal to mu. The final momentum of the object will be P2 equal to mv. The change in momentum is proportional to P2 minus P1. This is proportional to mv minus mu. And this is proportional to m into v minus u. This shows the rate of change of momentum is proportional to m into v minus u by t, or the applied force F is proportional to m into v minus u upon t. Now we remove the proportionality symbol with a constant k. F equal to km into v minus u upon t. That implies F equal to kma. Here, a equal to v minus u upon t is the acceleration, which is the rate of change of velocity. The quantity k is a constant of proportionality. The SI units of mass and acceleration are kg and meter per second square. The unit of force is chosen such that the value of the constant k becomes 1. For this, one unit of force is defined as the amount that produces an acceleration of 1 meter per second square in an object of 1 kg mass. That is, 1 unit of force equal to k into 1 kg into 1 meter per second square. So the value of k becomes 1. From equation 9.3, we get F equal to ma. The unit of force is kg meter per second square or Newton and is shown by the symbol capital N. This is the second law of motion. Here in the picture, you can see a cricketer pulling his hands downwards after catching a ball. Why does he do this? This action is to reduce the momentum of the fast moving ball and to exert lesser force on the hands so that he doesn't get hurt. And here again, you find an athlete doing a high jump on a heap of sand. What does this mean? This is to reduce the momentum of the athlete's body and to exert a lesser opposing force and prevent injury to the athlete. Now, let us derive the first law from the second law of motion. We know the second law of motion is given by F equal to m into a. Substituting acceleration a in this equation, we get F equal to m into v minus u upon t. This further leads to Ft equal to mv minus mu. Now, in this equation, if we consider the value of F to be 0, then both the initial and final velocities v and u will be the same for any time t seconds. That means if u equal to 0, then v equal to 0. That is, an object at rest will continue at rest, or an object in motion will continue in motion unless an unbalanced force is applied. And this is the first law of motion. That's all for today, children. Thank you.